How are you doing? So, apologies today, we were supposed to have a Zoom, but I'm unable to make the Zoom. So, I'm just going to do this recording for you and hopefully you'll be able to get through the next few pages. So, we're almost to the end of it. We possibly might finish this on the Monday, and then that way, when you return on the Tuesday, we will get straight into the next topic. Okay, so last lesson I was showing you how I did a video. Well, not really. I kind of actually just gave you the working out for these pages on how do we identify the intercepts. So just to refresh your memory, if it sits on the y-axis, it's a y-intercept. If it sits on the x-axis, it's the x-intercept. So here, the y-intercept is -1, the x-intercept is 2. Now, when we say if it has an x-intercept of 2, then the y-coordinate is 0. If it's got a y-intercept of -1, then the x-coordinate is 0. That's all it means. Then you looked at these ones and you had to find the intercepts here. So it would have been on these points and here and here. Oops, that's a mistake. It's only just there. Then you've got one there and one there. And then obviously here it only has a y-intercept and x-intercept, and here has a y-intercept. So that's what I was explaining on the worksheet. You don't worry about the extension question. If we get time when we come back to school, we'll go over them. So today you're doing points on the line, okay? And we're going to try and get to page 50 because I'm going to show you how to do parallel lines, but you're going to do this activity on your own on Monday. Okay, so as we know, when we draw a line, there are lots of points that lie on the line. So here's a line, okay? There would be many points that lie on the line, okay? If we were to draw a table of value, those would be the lines. So for this question here, it's saying list some points that lie on the line. So I'm going to pick points that are nice and discrete, discrete being whole numbers. So here's a point, here's a point, here's a point. I'm not going to go with this one here because it's like a half. Here's another point, here's a point, and here's a point. So list some of the ones that line there. I'm going to say -4, -5. Another one is -3, -3. Then it would be 0, 3, 1, 5, 2, 7. Okay, so there's some of the points that lie on the line. Example 2, it says, find the y-coordinate when x equals 3. So we go to where x equals 3, and we go up to the line, and then we find the y-coordinate. So when x equals 3, y is equal to 7. Okay, so that's the point there. Another way to find it is using the equation. So if I've got y equals 2x plus 1, y is equal to 2 times x plus 1. Well, if x is 3, that's like doing y equals 2 times substitute 3 plus 1, you'll also get 7. So 2 ways to do it, either from the graph or substitute it into the equation. Okay, let's move along. So let's have a look at this one. K is a point on the line, y equals -x, as shown. Okay, so there's K, it's on this line, that's negative. Okay, K obviously has a coordinate point of -2, but we don't know what this point is here. Okay, so that's a missing point. It says, complete the coordinates of K are. Okay, complete. The coordinates of K are. Okay, the only way to do it is to find the y value for K, we substitute x equals -2 into the equation y equals -4x. So y is equal to -4 times x Negative 4 times negative 2 is 8. So that's 8 there. Okay, so substitution is a key skill that you do when you're finding missing values. You can check whether a point lies on the line without drawing a line. If you are given a point, you can substitute. So there's the word again, the x and y values into the equation of the line to determine if the point lies on the line. So determine whether the point 13 and 25 lies on the line y equals 2x minus 1. Okay, so this is x and this is y. Sub x equals 13 and y equals 25 into y equals 2x minus 1. Now here, wherever you see the x, right, you're going to put it there. And where you see the y, you're going to put it there, okay? So in this case, that's 25. 2 times, it's times in between. 2 times 13 minus 1. That stays as 25. Now you need to make sure, so then what you do is you work out this answer, which is 26 minus 1, and what you'll notice is that equals 25. So here we say the left-hand side is equal to the right-hand side. Now when that's the case, we say yes, the point 13 over to 25 lies on the line. Okay? So this has to be true. Okay. For your exercise, I just want you to do 10, and I want you to do A to F. Don't worry about doing any other ones. Let me go into the extension question because this one is not so bad. So let's go to question 2. Find the coordinate of the point on the graph for the given x value for the graph. Okay, so we're going to substitute. Okay, so y is equal to 4 times x minus 5. Y is equal to 4 times negative 1 minus 5. Put that in your calculator and you'll get negative 9. So the coordinate is negative 1, negative 9. Y is equal to 4 times 0 minus 5. Y is equal to minus 5. So the coordinate here is 0 minus 5. Y is equal to 4 times 20 minus 5. Y is equal to 80 minus 5. Y is equal to 75. So this coordinate is 20 and 75. Okay, so that's it for today's lesson. But let's just move on to parallel lines because I'm just going to run it through with you, and then Monday you're going to complete the pages for me that I'm going to tell you in a minute. Okay, so on page 49, parallel lines. Parallel lines have the same, no, that's spelled incorrect. That should be gradient. Okay, so parallel lines have the same gradient. Okay, now if you notice, the distance between them is always the same. This is the gradient. So that's the key number you're looking for if you want to check that lines are parallel. So you're going to use Desmos. Desmos is a program it's an online graphing program on the internet, so you can use that. I want you to use Desmos, and I want you to put these in and answer these questions. What do the 3 equations have in common? Now, if you see what they have in common, all those x's have a value of 1 in front of them. 1, 1, 1. So what do the 3 equations have in common? The same gradient. Okay, make sure you put this into your booklet. What is needed for the lines to be parallel? What is needed? Oh, the gradient to be the same. The other thing, if we go back to part 1, what do the 3 equations have in common? Other things you can say is they are all positive. Okay. I guess that's it. They're all they're all positive and the same gradient. So that's what parallel lines look like. This one here, the equations of the 4 lines are listed below. Which lines is parallel to 1? Which line is parallel to 1? Now I'm assuming this is the 1, and which one's parallel to it would be 2. Which line is parallel to 3? Well, the one that's parallel to 3 is 4. Okay. The other thing is, and there's the exercise, which you're going to do on Monday. So that's it. So just go up to completing the answers up to page 49, and then just don't worry about the activity, and just do the exercise and submit. Okay, thanks, Year 9.